All right, this one is the temperature of the wire problem, very similar to the last one. I know I messed up on that last one. If you watched it, sorry, I forgot to tell you how to score it. I'll try to tell you on this one. Let me grab the scoring there. So anyway, this one is the wire that was heated up, and we have how far it is from the end of the wire and its temperature. I drew a quick little picture of it again. 0, 1, 5, 6, 8, 193, 76, 55. Excuse that scale there, I got a little low. Because I was going to have to do another trapezoidal roll. So the first problem is one like we did the first night. It says estimate t prime of 7. T prime of 7 would be the slope of that tangent right there. Again, we have no way to do this. We don't have a function. We can't take the derivative. So we're just going to find the slope between those 2 points. So that's the points between 6 and 8. So I did t of 8 minus t of 6 over 8 minus 6. So I'm using that secant line to approximate the tangent slope. I got 55 minus 62 over 2, negative 3.5 degrees per centimeter. And actually, if you're grading, just 1 point. So 1 point for getting that whole thing right. Part 2 says write an integral expression for the average value of the temperature. So again, you've now seen this in 2 tests. Average value is a pretty common thing that might show up. The average value of any function is just the integral of that function divided by the length integral. So the average value of t of x from 0 to 8, they wanted me to use a trapezoidal rule. So just like the last problem, I got a rectangle with 1, 4, 1, 2, 1, 4, 1, 2. Left-hand heights, 100, 93, 70, 62. Right-hand heights, 93, 70, 62, 55. We got 666 for the left, 545 for the right. Trapezoidal rule is the average of those two. Got 605.5. That's the area, and then I need to divide it by 8. So the average temperature, 75.7-ish degrees. If you're grading that one, 1 point for just writing the integral correctly, and 1 point for doing the trapezoidal rule correctly. Part C says find the integral from 0 to 8 of t prime. So the integral from 0 to t prime is, you integrate t prime, you get t. So this is t of 8 minus t of 0. T of 8 is 55, t of 0 is 100, 55 minus 0 is negative 45 degrees. Since this was an integral of a rate, what that means, you integrate any kind of rate, you get total, right? So if it's a speed, you get total distance. If it's shoveling snow, which there's a problem later coming to that, it's the total amount of snow. So in this case, it's the total change in the temperature from one end of the wire to the other. If you're grading that one, two more points, yeah? 1 for getting this right and 1 for getting your explanation right. And the last question, a little bit tricky, a little different. Said, is the data consistent with the assertion that the second derivative is always greater than 0? So second derivative is concavity, but we don't have a function. You could maybe try to draw it, but you can't tell what's going on in between, so concavity is a little bit weird. So what I did was I compared the second derivative to the first derivative. Remember, the second derivative, if the first derivative is positive, that means the function is increasing, right? So if we go back to the beginning, if the first derivative is positive, the function is increasing. So in this case, if the second derivative is positive, then the slopes must be increasing, or the first derivative must be increasing. So they have to match. So I just found all those slopes. So I found the slope, like I did up here, between 8 and 6. I found the slope between 0 and 1. And then between 1 and 5, and then between 5 and 6. Just using the same formula I did up here. So 0 to 1, so I just found that slope, then I found that slope, and then I found that slope. If all of those slopes are increasing, that means the second derivative would be positive, right? But they're not. So the first one was negative 7, the second one was negative 6 3/4, 5 3/4. So that is increasing at that point, it's going from negative 7 to something bigger, but then it goes back to negative 8, so it decreases again. So it's not always increasing. The first derivative is not always increasing, it means the second derivative is not always positive. 1 point for giving the idea of using those slopes, and 1 point for the final answer. I think that only gets me to 8 points. I wrote a note here that the last 9th point was for all the units, because there's units all over the place on these. So if you got all the units correct, then they give you that 9th point at the end. Hopefully that's it. Hopefully that helps a little bit.